So good afternoon, ladies and gentlemen. Welcome to lesson 1.5, and this is the last lesson under algebra. So we're going to look at multiplication and division of algebraic fractions. Algebraic fractions, and we're going to use these examples. The first example is coming from 2016 paper 2 specimen. This is coming from 2017 GCE. This one 2017 internal. So they don't miss in an exam. In case it can either be a multiplication or what? Division question. Okay, as you can see here, the first one is a multiplication, then you have division, then C, both multiplication and what? And division. So without further ado, let's jump right in and solve these questions. Let's start with the first one. So let me just create space here. So as you can see, the first one is 13k divided by 20a squared multiplied by 5 over 39 what? K squared. Okay? Now the first thing you should know before you do anything here is that is it a division or a multiplication here? So if it is a times your multiplication, you should know that you're going to just multiply direct, okay? Direct, and this is how you do it. Okay, this is how you do it. If it's a multiplication, multiply direct. If there's a division, I'll show you how we do that on the next example. So now, group numbers together. Group numbers what? Together. So we're going to say 13 times 5, right? Then times k. Are we together? Okay, we want to make what was one fraction. Even down here, we're going to multiply 20 times what? 20 multiplied by 39. Since here we've started with k, let's start with what? K, right? K squared is k times what? K. A squared is a times z. A times a, right? Okay, is it visible? Yes. I mean from, that's right. Okay, now, after reaching this point, remember this is mathematics paper 2. So, you can use the calculator and can give you the final answer for these just numbers, right? For numbers, but I don't want to teach you that. I want to make you understand how it's done without even a calculator. So you should know that whatever you are given here, there's a numbers can go in one number or the other. You check. 5 can't go into 39 without leaving a remainder. But 5 can go into 20, right?
Yes.
So 5 into 5?
1.
5 into 20?
4.
It's 4. Yes. Can 13 go into 39?
Yes.
How many times? 3 times, right?
Yes.
So this is the highest common multiple, 13 and 39. So 13, 13?
1.
13, 39?
3.
Okay. So we're remaining with the 1 on top, and then down we have 4 times what? 3, right? Okay. So let's go to variables.
Yes.
This k and one of the k's here cancel. That's all right?
Yes.
So in terms of numbers on top, everything is cancelled except 1. So on top, we are remaining with what? 1. Okay? Don't make a mistake of ignoring the 1 that is remaining on top there. What is 4 times 3? 12. How many k's do you remain with? 1. How many a's?
2.
So let's start with a's.
Yes.
So a to the power,
2.
then k. Can you reduce further from this point? No. So this is the final answer. The final answer. So the key is you cancel out variables and the numbers. Are we together?
Yes.
Okay. So as we are copying this, let me write down the second question.
Yes.
Okay. So the second question, which is question B, is 17k squared divided by 20a squared. divided by 51k squared over 5a. Okay? So look at this. You don't have enough time. Look at this. Here there is a division sign. Right?
Yes.
So if there's a division sign here, you're going to maintain the first part of this fraction, right?
Yes.
This question. So I'm going to say we're going to leave 17k squared the way it is, and the 20a squared the way it is, right?
Yes.
Then here we're going to introduce a multiplication sign. Are we together?
Yes.
Then this side we reciprocate. Reciprocation, it means the denominator becomes the numerator and the numerator becomes the what?
Denominator.
Exactly. So the 5a will be the numerator and 51k squared will be the what? Denominator. Then we can do like we've done with the first question, right?
Yes.
Okay, we just multiply direct. Group numbers together first, as 17 times 5 times how many k's? 2,
Yes.
So k times k, then times what? AI.
Yes.
Times a, okay, over, so this is a times, okay, this is kk, then a. Then on the denominator here we have 20 multiplied by 50 what? 51 times, do you have k? Yes, 2, right? 2 of them, which is k times what? K. And you have a what? Squared, which is a times z. A,
Yes.
need to show this this work. As you are working, you show your workings, right? Okay, it's very important. Now check. In terms of numbers, do we have a number which can go into the other? We have a 5, and this is 51, eh?
Yes.
So 5 can't go into 51. Can 5 go into 20?
Yes.
Yes. How many times?
4.
So this one, 5 into 20, 4 times. 7 into 17 into 17, 17 into 51. Come on. 17 goes into 51. How many times? 3 times. Okay? 3 times. Then let's go to variables. So in terms of numbers, we have 1, then down we have 3 times 4 times 3,
Yes.
Okay, so since we have 2 k's on top, this k and this k cancel, this one and this one cancel. So we on our final answer we shouldn't expect a k. Okay?
Yes.
You have one a there and that one. So on our final answer, on the denominator, we should remain with an e and a. Are we together?
Yes.
So on top, everything is cancelled except
1.
okay? Except 1. So therefore, the final answer to this question is 1 over, what is 4 times 3? 12. 12a. And this is the answer. We've simplified this. Remember the meaning of simplify. To simplify is to make it simple. Right?
Yes.
Yes, make it simple. Alright, can we go to question C?
Yes.
Question C. Okay. Let me just erase. Create space here. Look at question C. Question C is saying p squared cubed over 4. Am I right?
Yes.
Okay, then
Times 8.
times. Okay, so multiplied by 8 over
PQ.
pq divided by 2 p squared q.
Q.
Okay, now listen. So listen, here there's a multiplication,
Yes.
so we're going to maintain the first 2. Then here there's a division.
Yes.
And you remember, this number can be written as over what?
1.
Over 1. Okay? So we reciprocate here to introduce a multiplication what? Sign, So we're going to maintain here as p squared q cubed divided by
4,
multiplied by
8,
8 over p q multiplied by
1,
over p 2 what? 2p squared q. Okay, it's this simple, guys. Follow the rules. Okay, the steps. So here we're going to multiply what? Direct, right?
yes,
Okay. Number here is 1, 8, 1. It's just 8 in short, huh?
yes,
So you have 8 multiplied by p. How many p's do you have on top here? Only 1. 2, huh?
yes, 2,
So p times p times, how many q's? Q times q over, there's 4 times 1 times 2. Just the 4 times what?
2,
4 times 2 times, how many p's do we have? With 1, 3, right?
yes,
So p times c.
P,
How many q's? 2. Q times what? Q. Now remember, this is 8, right?
yes,
4 times 2 is 8?
8,
8, okay? Or 4 here, 1, 4 here, 2, 2 there, 1, 2 there,
1,
okay? But this is 8 and this 8 cancel, okay?
yes,
Okay, so in terms of numbers, we have an invisible.
1,
So this p and this p cancel. This one and this one cancel. Do we have any p on the numerator? No, right?
yes,
We can go to q. This q and this one cancel. This one and this one cancel. Okay. What are we remaining with on the numerator? Q, right?
yes,
On the denominator?
P,
P. And this is the
answer,
This is the answer. This is how easy this one, this lesson is. Now, let me make mention of this one. We've done with algebra. Alright?
yes,
We've done with what? Algebra. Just a recap before we go to the exercise. Let's review what we've covered so far.
yes,
What we've covered so far. We've looked at like and unlike
terms,
terms. Like and unlike, sorry. Like and the unlike terms. That is the introduction to algebra. Like and unlike terms. From there we look at simplify, expansion and simplify. Expansion and simplification, right?
yes,
Okay, and we simplify. Okay, expansion and simplify. After knowing how to expand, double brackets, single brackets, then we also looked at what factorization. Are we together?
yes,
How many types of factorization did we look at? 4, right?
yes,
Like for common factors, grouping terms, difference of two squares, then quadratic expression. And we also looked at application of algebraic of factorization to simplify. How to use our factorization to simplify fractions, right? Algebraic what? Fraction. From there, we looked at addition and subtraction of algebraic fractions, huh?
yes,
Then we also looked at, did we look at something else? Oh, this is the last one. Hi.
yes,
Division, multiplication and division of algebraic fractions. So, this is it's a must. Every subtopic I've given you here comes in the final exam. Okay? In the final exam. In paper one, you should expect 2 marks from simplifying, right?
Yes.
2 marks from factorizing, right?
Yes.
Okay? So that's all. Paper 1. Paper 2 under algebra, there is this one. Okay?
Yes.
This is the lesson multiplication. This is always 2 marks. Then there is that one where you're supposed to use to apply factorization, right?
Yes.
Okay, factorization is also what? 2 marks. Then there is that one, subtraction and addition of algebraic expression, where you are asked to express as a single fraction in its simplest form or terms, right?
yes,
And that is how many marks? It is 3. It's 3 marks. So when you add these, how many marks do you have? 7, huh?
yes,
Okay? So this is 7. Are you sure?
Oh, plus like
Okay, plus
4.
paper 1.
Oh.
Okay, so 6 plus This is 8, 8 plus 11, right?
Yes.
So 11 marks in algebra. You say, I know I can answer it. In the final exam, you find this. Are we together? So make sure you know how to go about these questions before we go to the next next topic. The next topic is very interesting to be topic 3. That one was introduction to mathematics. Topic 3 will be indices.
Yes.
Okay? In the what?
Indices.
So that indices is similar to algebra. It's just that there are just a few laws that we need to apply for indices, right?
Yes.
Okay. So that will be the next topic. Let's go to the
Exercise.
Okay, so this is the work. This is the exercise. So this is from 2017 internal to 2020. So 2017 to 2019 internal. So 2017, this is internal. Then there's 2018 GCE, 2018 internal, 2019 GCE, and 2019 internal. Then the bonus question here is coming from 2024 GCE. These questions don't miss in an exam, and it's just 2 marks. So all the best, guys. Bye bye to algebra. Let's meet in the next lesson, which is indices or index notation. Good. So I'm saying bye bye to this topic. I'm not saying you should also say bye bye to this topic. Okay? It's now your duty. So your blood is no longer in my hands because I have taught this lesson. So it's now up to you to make sure that you understand. Okay? Where you don't understand, ask. Are we together?
Yes.
So according to as far as algebra is concerned, I am an innocent soul. Yes. Your blood is not on my head. I am innocent when it comes to algebra. Okay? So all the best as you'll be answering this exercise.